Okay, so now for the most important of the concentration formulas. The second of the big chemistry formulas, the concentration formula. Measuring our chemicals in moles per litre. This, together with the mass formula, will be the two formulas you will use most often in your chemistry careers. And the concentration formula is as I say, it's the basic way we measure concentrations in chemistry. So it's moles per litre are the units. So concentration equals the number of moles of substance divided by the volume of the solution in litres. Volume has to be in litres. You want a formula triangle? This is the one that you would use. You're actually given the formula in the chemistry data sheet, so you don't actually have to memorise it, but really you use this formula that often that you really should know it off by heart. And of course we can use it in the various ways to calculate the different quantities. C equals N over V, N equals C times V, V equals N over C. So let's do some examples. Calculate the concentration of 300 mils of 0.165 moles. Okay, we've got the number of moles of the substance. Our volume, of course, has to go into litres though, so divide 300 by 1,000 to into litres. Single most common mistake with this concentration work is forgetting to turn mils into litres. Then sub into the formula, C equals N over V. N over V gets you your answer. Okay, this time we're after a volume. We know the concentration, 0.45 molar, and we know that contains 2.5 moles. And just a point on how we're expressing that as molar. So the unit is capital M, molar, and it's pronounced molar, and it's just as correct to say moles per litre. So either is correct. You could use that as the unit or that as a unit. So 0.45 molar equals 0.45 moles per litre. They mean exact same thing. So we've got the concentration, we've got the number of moles, we're after the volume. Volume equals N over C, N over C. It's easy, you've just got to remember to use the formula the right way around. Have your fail-safe way of doing it. A lot of people like formula triangles, but whatever way works for you. Okay, so 0.54 moles of sodium sulfate is added to 4 litres of water. What is the concentration of sodium sulfate, you might ask? Well, that's pretty easy to work out. We simply divide 0.54 by 4. C equals N over V. Do the division and you get 0.135 molar solution. Now we're looking at something subtly different. We know the concentration of sodium sulfate. What's sodium sulfate? Na2SO4. So our litre of solution contains 0.135 units of Na2SO4, but we see each of these contains 2 sodium ions. We're going to have twice as much sodium, thanks to that 2 in that formula, as we've got sodium sulfate as a whole. So we simply double the concentration of the original compound. And another little convention in our concentration work, the use of square brackets. A convention just makes it a little bit easier to right concentrations, especially when you're talking about ions and doing mathematical things. Okay, have a go at those questions. Submit your answers as required. Of course, when you're dealing with moles, we have got the mass formula that we can use whenever we like. So the two formulas are linked together, of course, by the number of moles. So you might be given a concentration and be asked for a mass, or vice versa. So this time, yeah, we start off with the concentration. We'll go from concentration to moles, and then once we've worked out the moles, we can then work out the mass. So concentration formula, N equals C times V. Then, once we've got the number of moles, we simply multiply that by the molar mass of sodium carbonate to give us the mass. Or we can go the other way around. We can start off with a mass, given the volume as well, we can work out the concentration. So mass to moles, first off, using the mass formula, N equals M over MR. Once we've got the number of moles, we've got the volume, we can work out the concentration. C equals N over V, etc. gives us our concentration. And like previously, we can do that extension to the concentration of an individual ion. Now we know the concentration of aluminium chloride as a whole, and we see each unit of aluminium chloride contains 3 chloride ions. So we've got 3 times as many chlorides as we've got of the whole thing. So we're going to multiply that concentration by 3 to give us the concentration of chloride in that solution. Do the questions, submit them online in the appropriate format. Another thing we can do is to convert between units. So you might be given moles per litre, you might be asked to convert that to grams per mil or something like that. And basically, you treat the top line and the bottom line separately, then divide at the end when you've done the appropriate conversions. So sodium chloride, molarity, moles per litre into grams per mil. Now you know by the definition of molarity, it's moles per litre. You know that means there are 0.5 of a mole in 1 litre of solution. That's what that concentration means. So you're wanting to go from 0.5 of a mole into 1 litre into how many grams there are in 1 millilitre, grams per mil. So you're going to need to convert the top line and the bottom line. So 0.5 of a mole into grams, 1 litre into mils. Once you've done that, you divide the answers that you get to give you your concentration. So, first of all, the top line, the 0.5 of a mole of sodium chloride into grams. We multiply, use the mass formula, we multiply by the molar mass, we get the mass of sodium chloride. Then we need to turn the 1 litre into mils. How do we do that? We simply multiply by 1,000. So the 1 litre equals 1,000 mils. Now once we've successfully converted the top line and the bottom line into the appropriate units, we simply divide it out. 29.2 divided by 1,000, and we get our concentration in grams per mil. Let's do an example or two. So sodium chloride, grams per litre, percent by mass, milligrams per gram. Now again, by definition, 0.74 molar is 0.75 moles per litre, meaning 0.74 moles in 1 litre of solution. So we go from moles per litre into grams per litre. So we have to convert our 0.74 moles into grams. Our 1 litre has to go into litres. That's handy, stays the same. So we do our conversion of the top line, moles into grams, divide it out. What do we get? 43.3 grams per litre. Second one, percent by mass. Now we've already done some of the work for that. We know that. Well, we know we've got to have mass of sodium chloride divided by mass of solution times 100 because it's a percentage. Now we know our mass of sodium chloride, we've just worked that out, that's 0.74 of a mole. We already know that that's 43.3 from the previous one. What we have to do now is convert our 1 litre into grams. Now 1 litre of course equals 1 mils, and there's that equivalence, 1 mil equals 1 gram, close enough. That's a really useful one to remember that, 1 mil equals 1 gram. Once you've done that, 43.3 divided by 1,000, then times by 100. Gives us our percent by mass. Milligrams per gram. Mass of sodium chloride in milligrams divided by a mass of solution in grams. 0.74 moles to milligrams on the top line. So we already know that 0.74 moles is 43.3 grams. So what are we going to do? Turn it into milligrams times 1,000. Then we've already got grams of solution. We turned 1 litre into grams previously. We know it's 1,000. Okay. All we need to do is divide 43.3 milligrams per gram. 8% mass by volume into moles per litre. Now here's where 8% mass by volume, best way to view about this is it's grams per 100 mils. So 8% by mass means 8 grams in 100 mils. We need to convert that to moles per litre. So our 8 grams has to go into moles, our 100 mils has to go into litres. Both of those are really simple calculations. So our 8 grams is 0.0755 moles, our 100 mils in litres of course is 0.1 of a litre. We'll do the division, we'll get our concentration. Okay, do those questions and submit those answers online. Need to see the working out for these.